Are there any questions on any of the assignments thus far? Let's make sure audio is in the correct place. There we go. All right. If there are no questions on any of the homework, what we're looking at today is trapezoids, and tomorrow we're going to look at kites. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called the bases. And well, the angles that are connected to the base sides are going to call the base angles. They kind of named it exactly what it is. Now, for any trapezoid, we're going to have two sets of base angles. These here and these here. And the other two sides that are not parallel are called the legs. So the sides that are not parallel are the legs, and the sides that are parallel are called the bases. And the angles that are attached to the parallel or the base are called the base angles. Pretty straightforward so far. Now, if a trapezoid has two congruent legs, if the legs are congruent, we call it isosceles. It's an isosceles trapezoid. Because when we talked about isosceles triangles, it was a triangle with two congruent sides. So that's why we call it isosceles trapezoid, because it has two congruent sides. And we do have three main properties with trapezoids. Isosceles trapezoids specifically. These only work with isosceles trapezoids. And the first one is that if a trapezoid has isosceles, then each pair of base angles is congruent. So if it's isosceles, the base angles are going to be the exact same. The second part, if a trapezoid has a pair of congruent base angles, then it's isosceles. Just the converse of what we said in the first statement. If it's isosceles, then the base angles are congruent. If the base angles are congruent, then it's isosceles. And lastly, a trapezoid is isosceles if and only if its diagonals are congruent. So this goes both ways. We won't have a converse for the isosceles trapezoid's diagonal theorem because of the if and only if. Because if we remember back, and it's been a day, because chapter 3, when we talked about conditional statements, biconditional means it goes in two directions. So if this is true, then this is true. And if this is true, then this is true. Both statements have to be true in either direction. So they don't need a converse because of it. So any questions on any of this here? All right. Let's look at the first example problem. Now, the printer did not print this picture well. And y'all are probably going to be the first group to actually be able to see this on the screen and actually be able to read what it says in the picture. The stone above the arch in the diagram is an isosceles trapezoid. Find the measures of angle K, M, and J. Now it's an isosceles trapezoid. So what do we know for sure? All right. These are congruent, yes? So what do we know is congruent for angles? Let's look back. Because if a trapezoid is isosceles, and we do have that, yes? Then what? Each pair of so J and M would be congruent, and K and L. As the base angles are the angles connected on the same parallel line. So the two angles on the same base, because the lines that are parallel are the bases. So these here are the bases. So the angles connected to those bases are congruent since it's isosceles. which tells us that the measure of angle K is 85 degrees. But that still leaves us with finding the measure of angle M and the measure of angle J. So what do we think we can do? Yes. What do we know about two angles that are between parallel lines? They're not going to be equal. We can say that all four angles add together to be 360, yes. And let's actually follow that, because that's a different way to look at this. Because we do know that these two base angles down here are going to be the same, yes? So for us, we can call both of them x. We can call it x and x. And so what we're saying is that x plus 85 plus 85 is equal to 360 degrees, because the sum of the interior angles of any figure add together to be 360. Now, if we add our like terms together, well, x plus x is, and then 85 plus 85, 170, is equal to 360. Then what can we do? We can subtract 170 from both sides, which tells us that 2x is equal to, these cancel. Any questions on any of this here? And then what can we do next? Add both sides by 2. Okay. So that means these two base angles down here are both congruent, and they are 95 degrees and any questions on this so far? Have y'all finished writing down the stuff we used to solve for x? Yes? I'm going to erase this. So the two base angles that we found, we had one that was 85 for the top two, and we had one that was 95 for the bottom two, yes? Add those two together. So it actually works out that these two here are going to add together to be. Because when we talked about parallelograms, the reason that we knew the consecutive angles added together to be 180 was because they were between parallel lines. Two parallel lines cut by a transversal. What do we have here? Two parallel lines being cut by a, they would add together to be 180. But the way that we did it still works just fine, since it is isosceles, and these two angles would be the same. Any questions on this here? Let's look at another example. Measure of angle B, measure of angle C, and the measure of angle D. What is one angle that we know for sure? A and D, because A, it told us, is, so measure of angle D is, and the reason we can say that with certainty is the fact that it is an isosceles trapezoid. And inside of an isosceles trapezoid, the base angles are congruent. What can we do next? Yes, because we know that the consecutive angles, the non-base angles, will add together to be 180. We can't just say consecutive angles because A and D and B and C are technically consecutive angles, but the base angles in isosceles trapezoid are congruent, so they won't add together to be 180. So the non-base angles will be supplementary. So we can take 180 and subtract 42. So both of these here are 138 degrees. And those there would be our answer. Now, part of the reason we can just do the subtraction from 180 is because, well, B and C are both just x. We don't have them defined as anything else. We're just finding that one angle. There's no other value with it. Because if it had been, say, 2x minus 7, we'd have to actually set it up and solve. Any questions on this here? Find all the possible missing angles. Well, the one we know for certain is angle S, yes? What other angles do we know? What would P be? Because this is it is a trapezoid. Is it isosceles? Right. PQ and SR definitely don't look to be congruent, but also because we're not told it, we can't assume it. And I think I've said this at least one point throughout the year so far. One of the biggest things I learned in geometry, especially the geometry I took in college, is that pictures lie. Just because it looks like it doesn't mean it is. So we can't assume it unless we've shown it or it is told to us. So we can't assume that this is isosceles. So P and S are not going to be congruent. It also means that Q and R are not going to be congruent. But I do know that S and R add together to be what? So I can take 180 and subtract what? So 180 minus 65, 115 degrees. So we can say that the measure of angle R is equal to 115 degrees. What can we say about the measures of angles P and Q? They had to be 180. Yes. But do I know what either one of them is? Are they anywhere related or connected to S or R? No. So can I find P or Q? No. All we can say is that the measure of angle R is 115 degrees. And that's it. Questions on this here? Okay, find all the possible missing angles in this trapezoid. And these here would be the parallel sides. F would indeed be 60 degrees because this is an isosceles trapezoid. What else can we find? What is going to be the measure of angle D? 120, and we can find it by doing 180 minus, which indeed would be 120. So this here would be 120 degrees. And E would be 120 degrees because the base angles are congruent. Base angles in isosceles trapezoid are congruent. And we can see that because we can do 120, 120, 60, and 60. Well, all four zeros are going to add together to be 0. 1, 2, 3, 4 And 6 is 16. Yeah, so 6, carry the 1. So we add it together to be 360. Any questions on this here? Do we need to see one more example of this? Because I feel like y'all have got this down, yes? All right. Okay. If the measure of HEF, so this whole angle is 70 degrees, and the measure of FGH is 110 degrees, is trapezoid EFGH isosceles? And that's what we want to figure out. Now, we can say it's isosceles if what is true? Angle F is 70. Because one of the theorems that we had so far said that if the base angles are congruent, then it's an isosceles trapezoid. Well, yes, these still would add together to be 180 degrees, even if it's not isosceles. Because we can say 180 minus 70 is 110 degrees. So can we say it's isosceles? Yes. Which means F is 70. And we could have gone about it the exact same way and said 180 minus 110, which would have given us 70. And that's it. Questions on this here? If EG is equal to FH, is trapezoid EFGH isosceles? Yes. It would be. Because the diagonals are equal. And that's going back to our isosceles trapezoid diagonals theorem. As if the diagonals of a trapezoid are congruent, then it will be isosceles. Any questions on this here? And I'll come back to this if we have time. All right. Let's look at the last few problems that we have. Find the indicated length of the diagonals indicated for each trapezoid. Because it should be in there. If it's not, that's fine. I'll have to fix it later. Yeah. Yes. Yep. Because if Kn, one of the diagonals is 22, the other one has to be 22. Because the diagonals are congruent. If it's isosceles, the diagonals are congruent. One of them is 22, so the other has to be 22 as well. DF is 8.7. So GE or EG is 8.7. That's it. And I mean, we could do more with those, but it really wouldn't be anything more than what we just did. Because I mean, we could set them up as equations and say one is 2x plus 7 and the other is 4x minus 18. What's the length? Solve for the value of x. Plug back in. It wouldn't really change anything. It just makes it look different. Doesn't change what we do. It's the exact same thing. Now this here is a little bit different. The mid-segment of a trapezoid is parallel to each basis. So if we find the mid-segment, or the midpoint of each leg, and draw a line connecting the two, we have the mid-segment. And I still find the way that they name things just so on point with this here. Mid-segment. Midpoint, middle, and it's a segment. It's a mid-segment. They named it 100% exactly what it is. And it's going to be in the exact middle of the two sides. Now, what's interesting with this here is that the length of MN is half the length of the other two sides added together. So if we take the other two side lengths, we can call it X and Y, and add those together, and multiply it by 1/2, or essentially divide by 2, we'll actually get what the middle is. The length of the mid-segment is equal to half the length of the other two sides, the other two bases. And it works out that way every single time. Whenever we have the mid-segment, it is bisecting the two legs. It's cutting the two legs in half, which is kind of neat. Any questions on this here? So, we want to know what this mid-segment's length is. So I'm going to call it X is equal to 1/2 of what? So it'd be half of PQ plus RS, which is 12 plus 28. Yeah, because we could say that MN is equal to half of PQ plus RS, because that is exactly true by the definition. But realistically, it's also just telling us that the missing length is equal to half of 12 plus 28. Yes. X is equal to 1/2 of 40. So X is equal to 20. So MN is equal to 20. Will MN, the mid-segment here, ever be bigger than 28? Because that wouldn't really make a shape, would it? Because if it's longer, well, now we have two other sides, because it's got to come down to those points and then back over. Is there any way that MN will be smaller than 12? No. Because that means that it would have to do something like this here if it was smaller than 12. And if it was bigger than 28, we would have to have something like this here. And in either case, we don't have a quadrilateral anymore, because those would be considered two more sides on either side. Well, that's kind of helpful, isn't it? Because if I get a number that's bigger than 28 or less than 12, it probably ain't it. And what's interesting is it's in the exact middle. Because what's the difference between 12 and 28? (28 minus 12)? 16, yes? So the difference between these two is 16, yes? What's half of 16? 8. So this distance here, if it's in the middle, would be 8, and this distance here would be, what's 12 plus 8? What's 28 minus 8? What was our answer? It will be in the exact middle between these two here. It will always be in the middle. Now, 12 and 28 is a little bit easier if we kind of can find the middle that way, but when we're given decimal, it's a little bit harder to see. But it's still going to hold true that our mid-segment's going to equal half of what plus what? Yes. And the order in which we put them in doesn't matter inside that parentheses, because addition is, if I'm remembering the correct word, is commutative or associative. Terms are slipping my mind at the moment. It's one of those two, which really is saying that we can add any two things in any order. I think it's commutative. I'll look it up and double check. Been too long since I've used commutative, or actually reference commutative and associative properties. I think it is commutative. Now, at this point here, just like the last one, we could actually plug that whole thing into the calculator. Because if we have numbers, all numbers on one side of the equation and no variables, we can plug it in. Or if we do this by hand, we would have 1/2 of 8, 5 and 9 would be 4, carry the 1. 8, 9. 0.4. And half of 32.4, 16 point. So this length here is 16.2. Well, any questions on this here? I don't like this. Okay. There we go. We'll get to this one here in a minute. I need to redo these notes. I want to look at this one here first. Are these on? Those are on here, yes? So we're skipping 12. We're going to go to 9, and then I think the next one will be similar to this. Middles. They give us one of the bases in the mid-segment, but they don't give us the other base. I want to look at these first. Is the theorem still going to hold true for this here? Well, yes. Even though it looks different, it still holds true. And it's telling us that 19 is equal to 1/2 of what? Mm-hmm. 13 plus x, because we can just call the missing side x. We want to figure out what it is. What can we do next? We can distribute with the 13 and x, yes? Is 13 divisible by 2? No. We can do it. We would get a decimal, yes? And we would have a decimal with x. We'd have a decimal with both, yes? This is also why when we solve equations, how we say you want to do addition and subtraction first. Don't divide everything if we have 3x by 3. Is it wrong to divide at that point by 3? Well, no. But what ends up happening is we get decimals all over the place. So we try to do it last. So it is possible to do that. And we can do that here. As we do have one more, and I'll show you another way to do this. But let's multiply through by 1/2. So we would have the 19. What is 1/2 times 13? 6.5. Plus 1/2 times x is Well, 0.5x. Now, if we were dealing with all fractions, we could have left it in fractional form as 13 over 2 and 1/2 x. But the other number, 19, is a whole number. It's going to be easier to have it as decimals. Well, what we can do next is subtract 6.5 from both sides. Exactly. Is equal to 0.5x. And one of the ways, that you could have done the subtraction here is that I would have written down the 0.5 because I know that the 0.5 here and this 0.5 would make a whole, which makes 6 into 7. 19 minus 7 is 12. And then we would need to divide both sides by 0.5. Now, it is actually not going to be 6. Now, kind of like what we said earlier, the mid-segment can't be bigger than the smaller base, the 13. So it has to be bigger, yes. It actually is 25. Because again, the mid-segment has to be between the other two sides. Mid-segment has to be between the other two sides. So if one of the sides is 13 and the mid-segment's 19, well, the third side has to be bigger than 19 because we still need the mid-segment to be in the middle between those two numbers. Mm-hmm. Yes. Because it's in the exact middle, yes? The difference between these two here is 6, so the difference between these two has to be 6. So we get to 25. There is another way that we can do this. You can watch this and we'll write it down like this for the next one. What happens if I multiply 1/2 by 2? It becomes a whole 1, yes? So these would simplify out. Well, if I do it to one side, I have to do it to the. So 38 is equal to minus 13 from both sides. X is equal to. And we get the same thing. So let's look at this one here. How can we go about solving for the third side? Okay, which is? So the difference between the top and the middle is 1.1, yes? Which makes the difference between the middle and the bottom. So it would be 6.6. Now, if we worked it out, we could say that 5.5 is equal to 1/2 of plus x. Now, I wouldn't multiply it through by 1/2 because that'd be a little funky with decimals already. But what we can do is multiply both sides by 2. These would cancel out. Now, 2 times 5.5, we could do that in a calculator, and it would actually tell us that it is 11 is equal to 4.4 plus x. We can subtract 4.4 from both sides, telling us x is equal to, well, 6.6. And that's it. That's all we'd have to do for this here. And really, either method works just fine. Well, any questions on this here before we look at the last one? Because we skipped this one here. Change 23 to 2x plus 4. I have no idea how this is going to work out with the value of x, but we're going to give it a shot. Because I want to show you one similar to this here. Because we can still solve it. Now it tells us that the midsegment is, so we can say that 29 is equal to 1/2 of what? Oh yeah, this is going to be fun. Well, what we can do first, there's two things, one or two things we can do. We can either combine like terms or by 2. We can combine like terms first. So 29 is equal to 1/2 of 13x, because 2x plus 11x would be 13x. Then what can we do next? Now we would multiply both sides by 2 because we want this 2 and 1/2 to cancel out, simplify to 1. If this works out to be a whole number, I am going to be genuinely surprised. 2 times 29 is 58. Is equal to 13x plus 6. Which tells us that 52 wow. Then we would I was thinking the same thing when I noticed that x, we'd have 13x. Now, if we want to see what the other two sides would be, we can plug it back in. So we could say 11 times 4 plus 2. 11 times 44 plus 2 is 46. So our side here would be 46. Over here we would have 2 times 4 plus 4. Well, 2 times 4 is 8, and 8 plus 4 is 12. And the distance between this and this is 17, and here is 17. So it does work out exactly to be 29. But we can do the exact same like this here. Heck, even if we didn't have 29 in the middle, we could have 3 equations with variables and still do the exact same thing. Because the midsegment will always be equal to half of the sum of the other two sides, the other two bases. And that's it. And this is your assignment here.